Hello everyone, I welcome you all for the video lecture in the Python programming language. Today, let us discuss a topic, variables. Variables are fundamental building blocks in Python, allowing us to store and manage data efficiently within our programs. They are dynamically typed and incredibly flexible, adapting to various data types as needed. What is a variable in Python? Variable serves as symbolic names that refer to objects stored in the computer's memory. Unlike some other programming languages, Python does not require explicit declaration of a variable before its assignment. Consider x is equal to 5 or name is equal to within double quotes alias. Here, x and name are variables labeling the stored data. Essentially, variables act as convenient labels, making it easy to reference and manipulate data within your code. Syntax rules for Python variables: valid starting characters. Variable names must begin with a letter or an underscore. They can contain letters, digits from 0 to 9, and underscores only. Names cannot start with a digit. Python's reserved keywords like if, for, while, etc. cannot be used as variable names. Python is case sensitive, meaning age, capital age, and all caps age are treated as distinct variables. Python is case sensitive, meaning the upper case and the lower case for the alphabets will be treated differently. Naming conventions, descriptive names. Always use names that clearly indicate the variable's purpose for enhanced readability and understanding. For multi-word names, adopt snake case to improve readability. Avoid ambiguity, refrain from using overlap short or ambiguous names that might confuse other developers or your future self. Good examples include total volume and user age, which are self explanatory. We can use camel case, snake case if we want to have multiple words. Yes. So, in order to avoid ambiguity, we need to name the variables with proper meaning. Data types Python variables can hold are numeric types, text type, boolean type. In collection types, we have list, tuples, dictionaries, and custom objects. Numeric types includes integers, example 42, floating point numbers, example 3.14. Text type includes strings, example within double quotes hello for textual data. Boolean type are true and false for logical operations. It may be either true or false. And collection types includes list, tuples, dictionaries. Lists are ordered mutable sequences. Tuples are ordered immutable sequences. Dictionaries are unordered key value pairs. Custom objects are instances of user defined classes and more complex data structures. Dynamic typing in Python. Runtime inference. Python automatically determines the type of variable at runtime based on the value assigned to it. The type of a variable can change dynamically by reassigning it a value of a different type. For instance, variable is equal to 10 can later become variable is equal to within double quotes 10. No explicit declarations. This dynamic nature eliminates the need for explicit type declarations, making Python code more concise and flexible. Variable scope in Python. Local variables, global variables. Local variables defined inside a function, they are accessible only within the function. Global variables defined outside any function, they are accessible throughout the entire program. Global keyword to modify a global variable from within a function, you must explicitly use the global keyword. Lifetime and accessibility. Variable scope dictates their lifetime and where they can be accessed in your code, influencing program flow. Multiple assignments and typecasting. Assigning multiple variables in a single line, a comma b is equal to 1 comma 2. Assigning the same value to multiple variables simultaneously, x is equal to y is equal to 0. Typecasting functions for explicit type conversions, int, float, string. Converting string to integer or float, number is equal to int within double quotes 10 comma price is equal to float within double quotes 9.99. These techniques offer powerful ways to handle variable assignments and ensure data compatibility across different types. Common use cases of variables in Python: input and data storage, counters and accumulators, configuration and state, intermodule data. Variables are essential for capturing user input and storing various types of program data. Counters and accumulators are widely used as counters in loops and accumulators for summing values. Configuration and state variables hold critical configuration settings or track the current state of an application. Intermodule data facilitate the seamless passing of data between different functions and modules within a larger program. Summary: they are symbolic labels for data stored in memory crucial for program logic. Creation by assignment: variables are created simply by assigning a value without requiring explicit declaration. Naming practices: we have to adhere to clear naming rules and conventions for maintainable and readable code. Python's dynamic typing offers flexibility, allowing variables to hold various data types and change them at runtime. Scope and casting. Understanding variable scope and the ability to perform typecasting significantly enhances code quality and robustness. Thus, we have come to the end of today's session. Let us discuss another topic. Until I say thank you all and thank you all.